2, 3, hello, can you hear me? Excellent, we're off to a good start. Tambi, you just want to get your laptop out of the way? We do this thing where we get here an hour early and you plug everything in, you get it all set up, you get it ready, and then 5 minutes before someone says, oh no, we need to plug my laptop in for the intro. Sorry. There we go. No, that's all right. Okay, is this thing on? Is this working? Let's see if we can see. All right, let's do this. Good morning, Xpand. How's everybody doing? This is me, Dylan Beattie. I'm Dylan Beattie on all the things. Find me on Twitter, Mastodon, Threads, Instagram, whatever, email. I love chatting about the kind of stuff I'm going to talk about. I love hearing the kind of stories about the sort of things that all of you are working on. I'm a Microsoft MVP. I run a .NET user group in London, where I live. And I invented a programming language once as a joke. And now, 6 years later, I'm the project manager of the joke. And the joke has a reference implementation and a test suite. Now, the two questions that people always ask me, the first one is, where's your accent from? I'm British, I live in London in the UK, but I was born in Kenya, I grew up in Zimbabwe, I am loving the heat. This is wonderful, I'm enjoying every second. The second one is, do you have any stickers? Yes, I have stickers. Come and find me over the next couple of days, grab some rock and roll themed developer laptop stickers, and if you want to swap them for a good story, there are two things about this talk that you need to realize. A lot of the stuff that I'm going to talk to you about today is stuff that I learned traveling around doing events like this in Ukraine and Russia and Belarus, because I used to do lots of events out there. And you get a chance to talk to people who are working on the same stuff you're working on, but from a completely different background. And then, the world has changed a lot in the last 5 years. The world has become a pretty scary place. And I sort of thought, do I still want to do this talk? And I thought, yeah, everything in here is people trying to figure out ways to communicate better. Because communication leads to understanding. And without understanding, we're never really going to figure out how to make all this stuff work. The second thing about this talk is that it keeps evolving. First of all, I would go out and do it in front of people like yourselves, and people come up afterwards, and they tell me about this cool thing they found, and I roll that into the talk. And then people started putting versions of it up on YouTube. And you know what YouTube is like, right? Like people on YouTube, there's no such thing as plain text. Of course there's such a thing as plain text, says Braden. Yeah. And apparently because Arnold Schwarzenegger's going to go back in time to kill my parents because of plain text. Now, I don't think this guy has a point. But a lot of the wonderful things about having talks on YouTube that get a lot of views is people add things you would never have found out with your own research. And so there's a couple of points in the talk where I used to get it wrong. And I would say something that I'd found on Wikipedia or in some old reference manual. And then some guy who was doing mainframes in the 60s pops up in the comments and tells me what really happened. So we're going to talk about plain text. Yep, plain text for the next 40 minutes or so. Now, a lot of people like asking developers, hey, what do you think about text? Because we use text all the time. Like source code, yeah, plain text files. YAML, plain text files. JSON, JavaScript, all these different things. Deep down, we think it is this thing called plain text, which means that your life is going to be easy. And a lot of the time, when folks say plain text, what they actually mean is this. They mean ASCII. Sometimes they mean 7-bit ASCII. And the thing you've got to realize about 7-bit ASCII, this has been around probably longer than any of us have been alive. Like this predates everyone in the room, I suspect. And this was designed. ASCII was designed by smart people to solve the problems they had. Thing is, those were the problems they had in the United States of America in 1965 when computers looked like this. So ASCII is full of weird things that kind of don't make sense anymore, but backwards compatibility means we're stuck with them. Now, ASCII was designed to run on teleprinters, computers that did not have a screen. They had a thing called a carriage. And so you had this block of control characters. The first chunk of ASCII is about how to make your mechanical teleprinter do the things that you want. And so we got this block here. We've got a Control A as the start of a heading, and Control B as the start of text. And if your teleprinter is kind of going do, and you need it to stop now, you'd hit Control C. And that one survived. And we still have that. And I still hit that about once a week when I make a mistake in one of my programs, and it just goes into a little infinite loop. Now, this little chunk here, horizontal tabs, line feeds, we got this whole kind of ongoing discussion about how do you end a line in a text file, because Windows does it one way, and Unix and Linux and Mac OS, they do it another way. Well, this is a teleprinter, and this is the carriage, and you print your line of text, and then, to print the next line, you need to return the carriage to the left-hand side. That's a carriage return. And then you need to feed the next line of paper through. That's a line feed. Now, teleprinters were pretty primitive, but one of the things they could do is they could do bold. They didn't have fonts, but you could back up and then print the same line again. And it kind of would smudge it a little bit. You'd get this bold effect. And this meant that a carriage return on its own was useful. Line feed on its own, not so much. Now, we have this situation now. Linux machines say, hey, yeah, \n, that's how you end a line. And Windows says, no, you need a carriage return. Because Windows doesn't have a carriage. But Windows evolved out, so Linux evolved out of Unix, and Unix evolved out of a system called Multics. And Multics was the first operating system in history that had a device driver. And so you could put a little bit of code between your terminal and your teleprinter that would say, hey, when you see this /n, also put a carriage return in. But just make that happen so we don't need to put it in the text file. Windows 11 out of Windows 10, they skipped Windows 9 so they didn't confuse people, Windows 8 out of Windows 7, all the way back to MS-DOS, all the way back to CP/M. And CP/M was designed to run on the cheapest computers possible. They didn't have any device drivers. So you had to have the carriage return new line in there. Now, the next chunk of ASCII we get to is this block here. They had to make decisions with ASCII, like how much punctuation are we going to support? And if any of you worked in typography or book printing, you know that there are way more characters than this you'll use when you're printing a book, but they're like, nah, we don't have space for that. We'll have one straight quote, we'll have one little, and it's a minus sign and a hyphen and a dash and all these kinds of things. The decimal numbers, or actually these are the Arabic numerals, aren't they? These are the East Arabic numbers. And you say to folks in the US, hey, do you want your children learning Arabic numerals at school? And they get all frightened because they don't know anything. The block of numbers is interesting because one of the things computers have to do a lot is they have to convert a machine representation to a human representation and back again. So the machine can read it, but then the human can read it, and then the machine can read it. And so all you do to turn a ASCII decimal digit into its binary representation is you just look at the little half, and that gives you the binary value of 1, 2, 3, 4, 5, 6, 7. Now, the Latin alphabet, this block of letters here, you ever looked at this and thought, why is uppercase A 65 and lowercase a is 97? Why did they choose those two numbers to represent the start of the Latin alphabet? And the reason is that they're separated by 1 bit. So if you need to do a case-insensitive search or a string comparison, all you do is you switch that bit off. And then they end up the same, and you can do fast searching even on kind of low-powered 8-bit computers, which is what they were, actually 4-bit computers is what they were working on in the days. And then right at the end of ASCII, way down the bottom here, ASCII code 127 is del, delete, kind of floating around on its own. And the reason why delete is 127 is if you're saving your program on one of these, you can't fill the holes back in. You can't erase data. All you can do is you can punch out all the rest of the holes, and then no one can see what was on the tape before. So the Americans turn around, and they go, hey, 127 characters, all you're ever going to need. And the rest of the world goes, what? We can't work with this. Now, depending on, some cultures and languages were kind of close to US English. Some were very, very far removed from it. Now, I grew up in Zimbabwe, which meant I grew up speaking English and using dollars and cents. So I didn't see a problem with ASCII till I moved to the UK when I was 10 years old, and I was trying to print some homework. And I hooked up the printer to my 286 retro computer, which is probably in the museum out the back there running old games right now. And when I tried to print it, I got this. And I was like, what? Why can't I print the pound sign? This is important. Turns out that this symbol, pound sterling, British currency, that didn't make the cut. The US ASCII design, they're like, we don't need that. We don't have that in America, so yeah, we'll use it for something more useful. A lot of people around the world, they were looking at ASCII, and they were looking at this, we got this 7-bit encoding, and they went, well, hang on. we've got 8 bits in a byte. There's this whole block over here that we could be using to do our own stuff. Is anyone using this? And of course, nobody was in control of it. There was no standards organization mandating what we did with the other half of 8-bit ASCII. And so everyone jumped in and went, yay, we're going to use this to solve our problem. All of them. And we ended up with this chaotic, incompatible mess of, if you've ever seen a thing called a code page is just a set of rules that says right now, in this document, in this application, on this computer, on this date, this is what the top half of ASCII means. Now, one very kind of famous, influential code page was this one. It was code page 437. It was the default with the IBM PC, which shipped in the early 1980s. And what they did with this, they kept the basic 7-bit ASCII. The top half, they put in most of the characters that were necessary for Northern and Western Europe. And then they put in this block here, which is line drawing and box drawing characters. And then they put in half of the Greek alphabet. Anyone know why half? Like, you couldn't use 437 to write emails in Greek, but you could use it to do your maths homework and your physics homework. They picked the Greek characters that were used in physics, but not the ones that were actually used to read and write Greek. And then somebody went, well, hang on, the IBM PC isn't a teleprinter. We don't need carriage returns and stuff. And so they took the top block, the control block, and said, well, we can use this for little dingbats and smiley faces and playing cards. Now, what this meant in practice is if you've ever seen an IBM PC crash really, really hard, you get the screen full of gibberish with little smiley faces because the computer's laughing at you because you screwed up so bad. Because it's taking all of the low-valued opcodes in memory and it's dumping them using code page 437, and so you get playing cards and smiley faces coming out on the screen. Now, there's one code page that I thought was really clever. There was an international attempt at encoding the Cyrillic alphabet, which is used for Russian, Ukrainian, several other languages in that part of the world. And it didn't really work very well, because the international standard would take a word like privyet, which is, anyone here speak or understand Russian? Privyet is hi, like hello, sort of good morning kind of thing. And you'd encode it using the international standard. But a lot of software would remove the 8th bit. There were word processors that used the 8th bit as a spell-checking flag. A lot of email systems, actually to this day, email is still a 7-bit protocol. So if you weren't encoding your emails, you would lose that 8th bit in transit, gone. And then you'd turn that back into ASCII and you'd get, we don't know what this is at the other end. So a bunch of folks in the Soviet Union came up with KOI-8, the Kodobnama Informatsiya 8-bit. And what they did is they said, all right, we're going to take Russian, and we're going to map it onto, it's not alphabetical order, we're going to map it onto the ASCII characters which sound the same. And so if it got mangled in transmission, what you'd get at the other end was kind of gibberish, but you could go privyet, all right, I think I know what this says, which I think is quite a neat hack. Now, I did a version of this talk a couple of years ago. Somebody comes up to me afterwards, and they said, do you know about the Harry Potter book? I was like, no. Tell me about the Harry Potter book. And I found this wonderful story, 2002. Now, this is one of those little things that there are screenshots kind of floating around Usenet, so you have to fill in some of the gaps. But there's a woman called Svetlana, and she's in Russia, and Claudette is her friend in France. And they're pen friends. They're emailing backwards and forwards, and they're in like the Harry Potter fan club. And the new Harry Potter book has just come out, but it's not out in Russia yet. And so Svetlana sends this email to Claudette and says, hey, yeah, send me the new book. That'd be amazing. Here's my address in the Russian alphabet. Please copy it carefully. And puts in apartment building in Moscow. And clicks send on Outlook 2000, on Windows XP or whatever they were running. And Claudette gets this. And of course, that's what the Russian alphabet looks like. I'd better copy that out really carefully. Now, this is the same data. This is exactly the same set of underlying numeric values, but it's being rendered using a different code page. It's gone from KOI-8 into Windows 1252. But Claudette follows the instructions and copies that down, exactly. And then somebody in the Russian postal system gets hold of this envelope and goes, I know what's going on here. And they translate it back, and the book gets delivered. All right, folks, I want you to get your phones out for this next part, and I want you to open whatever you use to listen to music, like Spotify or Google Play, whatever you find albums and records on, And I want you to search for this word. Anyone found anything? Uptown Girl, Billy Joel, live in Leningrad, 1987. Billy Joel becomes one of the first Western artists who's authorized to go and perform a concert behind the Iron Curtain. And they record this concert he does in Leningrad, and they release it. And it's called Concert. But on the record cover, they spell the word concert in Russian. So, K-O-N-C-E-R-T. And then at some point, somebody in the Billy Joel's record company office is like, oh, I need to put that into the computer. And they look at that, and they look at their American keyboard, K-O-H-U-E-P-T. Doesn't matter, right? Because it's just like an internal database for stock control. Then streaming happens. And so Apple and Google and Spotify, they go to the record companies, and they say, do you have like a database of all of your records that we can use for licensing? And like, yeah. And there it is. And so Kohuept, which is not a word, has just become the name of this album based on this transliteration problem. Now, I told this story, and someone comes up to me afterwards, and they told me about something else that I just thought was just a wonderfully excellent hack. This is in Russian, and this does not mean anything. This is complete gibberish. Now, if you type this sequence of letters on a Russian keyboard layout, these are the keys you press. And if you type that same pattern onto a British or Western keyboard layout, it spells this. And Google knows that. And if you go on Google and you've forgotten to switch your keyboard from Russian back to English, and you search for that, Google goes, oh yeah, I know this one. You're looking for Taylor Swift, and you forgot to switch keyboard layouts. And to me, there must have been some engineer at Google who was like switching between Russian or Ukrainian and English, and they just got fed up of forgetting to it, and so they went and implemented this feature. And I think, that's not an encoding, that's not a language, alphabet, anything. That's just a beautiful hack that makes the world easier to navigate. Now, this code page system, it became chaotic. Pretty soon this is the footnote to the Wikipedia page about code pages. Like, if you wanted to send email in Arabic, you had to know, well, are you on DOS Arabic, or are you on Apple Arabic, or are you on PostScript Arabic, or IBM Arabic, which was different. And so even if you could agree what language and alphabet you wanted to use, you had to know what kind of computer was your recipient using, and where did they buy it from, and what version of the operating system was it running. And when we invented the web, and when email went mainstream in the 90s, we needed a better system. And so the Unicode Consortium, Unified Coding, was established. And that mission statement I actually think is really, really nice. It's this. It says to provide a single consistent way to represent each letter and symbol needed for all human languages across all computers and devices. Now, there are 3 points here. One, all computers and devices. If you want everybody in the world to use your stuff, you've got to make it really good, and you've got to make it free. Free as in beer, free as in speech, no license, no patents, no fees, no subscriptions, nothing. They did that. It works really well. That's how the world manages to communicate now. All human languages, not just the ones we're still using. There's folks out there studying ancient Sumerian. There are folks out there doing research with Egyptian hieroglyphics. They should be able to do their research with Unicode as well. And that gets us down to a single consistent way to represent each letter and symbol. How many letters are on this slide? Show of hands. Who thinks there are 4 letters here? Who thinks there are 3? Who thinks there are 2? Let's ask JavaScript. JavaScript says 3. Let's put it in a monospaced font, because no one writes code in a proportional font. There you go. Now, this is Dutch. And Dutch uses almost the same alphabet as English, apart from this letter here. And Dutch cannot decide whether this is a letter or not, because they keep changing their minds. Now, for a long time, the 2 countries where there's a lot of Dutch speakers, one is Belgium, one is the Netherlands. And for a long time, this tile existed in the Scrabble game in Belgium, but it didn't exist in the Netherlands. So if you're playing Scrabble with the family over the holidays, and someone writes this word and says, look at that, 7-letter word, I get my bingo, I get my 50-point bonus, and you're like, oh, no, sorry, Aunt Marie, you're in the Netherlands now. That's only a 5-letter word. And there'd be a big argument over the dinner table and people throwing food and stuff. This is a bad idea. So eventually the Scrabble people went, no, it's two. Two separate, that's not a Scrabble tile anymore, it's two. So that's one set of standards, but if you drive around the Netherlands now, you'll see IJ capitalized as a single letter on road signs and shop names and everything. So even within these two neighboring countries that share this common language that just has this one weird letter, they still can't decide, like they have one rule for the road signs and another rule for board games. And we are just getting warmed up. Let me introduce you to some friends of mine. So this is Francois Borda, who's a French archaeologist, and this is Motley Crue, a rock band from Los Angeles, New York. And Francois, the archaeologist, went to the Motley Crue concert. Now, this is an English sentence, right? You'd read this in an English magazine or website. You'd be like, yeah, that makes perfect sense. But these 4 letters here, they do not appear in the English Latin alphabet because we borrow letters from all over the place. We've got these 4 glyphs here. We've got a little C with a cedilla, like a little tail underneath it. We got the AE here, which is a thing called a typographer's ligature. And then the O and the U here, this is the heavy metal umlaut, which rock bands put on their name because it thinks it makes them look hardcore. And when Motley Crue toured in Germany for the first time, they didn't know why the audience was going, Mötley Crüe, until someone sat them down and went, you know, that's a letter of the alphabet that they have here? And yeah, they had no idea. Now, making Motley Crue look stupid, yeah, big deal. They kind of look stupid anyway. Let's meet another friend of mine, Magnus. Magnus, now a lot of people think this is Magnus Martinsson. This is Magnus Mortensson. Magnus is Swedish. He's a Microsoft Azure MVP. And a couple of years ago, Magnus is on his way to the United States to go to a conference in Redmond. And he got stopped at United States passport control. And he has a Swedish passport. And the Swedish passport has his name, Mortensson. And then down the bottom, it has this machine-readable strip. This has to be in 7-bit ASCII. He also has an airplane ticket. Now, his passport is from the Swedish government, and their rule is that if your name is Mor, with an or, with a little a with a circle on it, that becomes AA when you turn it into ASCII. People who print his airline ticket, they don't know that. They just take the little circle off the top. And so he ends up trying to get into the US with a passport that does not match the name on his airplane ticket. Yeah, the Americans love that, right? They're really friendly, understanding. No, not so good. Now, Magnus is, he's a sort of well-dressed guy on his way to a Microsoft conference. But you can see how for all kinds of people, this problem, a text encoding problem, could turn into really, really serious consequences. Let's take a look at this. We've got a list here of cities in Europe. We've got Berlin, we've got Aachen, we've got Zurich, we've got Aarhus, and we've got Örebro, which is in Sweden. Now, we're going to put this list in alphabetical order. Show of hands, who thinks list 1 is alphabetical order? 2? 3? Who thinks this is a trap? These lists are all in alphabetical order, depending who you are and where you are in the world. We're going to put some data here. We're going to use Microsoft SQL Server, and I'm going to create a database table, and I'm going to put my cities in my database. And then I'm going to go, all right, select star, there we go. We got our 5 cities in there. Let's find Örebro. And it's like, and I'm like, nah, come on, I literally just put that in. What do you mean it's not there? Maybe it's case sensitive. Are these strings even the same? If Örebro equals Örebro, and it says, no, they are not. And so I'm going to say, all right, well, what if I collate them using Latin 1 general? CI here stands for case insensitive. AI stands for accent insensitive. And at this point, it goes, oh, yeah, well, now they're the same. This is what a collation is. In a database, a collation is basically a set of rules for saying this is alphabetical order. These strings are equal, and if they're not equal, it tells you which one of these comes first. Now, if we do the same thing, select from order by name, we get what looks to me as a native English speaker, this looks to me like alphabetical order, A, B, O, Z. If I do Latin General 1, yeah, that's the default on this server, that's fine for me. If I do it with the Finnish and Swedish collation, the town of, or the city of Örebro in Sweden is spelt with the letter Ö, and the letter Ö is the 29th letter of the Swedish alphabet. So it comes after Z. And so suddenly Örebro has moved to the end, and now I'm going to use the Danish and Norwegian collation, and suddenly Berlin is first. and Aachen and Aarhus are at the end. Now, Aarhus is one of those things that just the human beings have come up with something so complicated the computers are never going to be able to get it right. Because the city of Aarhus, Denmark's second largest city, was officially, it changed its spelling twice. In 1948, after World War II, Denmark went, yeah, we want to be more Swedish and less German, and so they extended their alphabet. They had the Danish spelling reform, and they added 3 new letters to the Danish alphabet, and then they changed the name of a whole bunch of people and businesses and places. So if your name started with an AA, pronounced like an O, you'd become Aarhus with a little circle on the top. And that meant you moved to the end of the alphabet. So Aachen is in Germany, that doesn't move. Aarhus is in Denmark, that does move. Then in 2011, because they were worried about search engine optimization for tourism, the city of Aarhus changed its spelling back, but that doesn't move them in the alphabet. And so we have this situation now where this list on the left-hand side, if you're in Denmark or Norway, this is in alphabetical order, and it makes perfect sense. And anyone who is not Danish or Norwegian is looking at this going, no, it can't be in alphabetical order. They start with the same letters. How can they be in different places in the alphabet? There's not enough context. If you actually have to solve this problem for real users, the only way to do it is to put extra information into your database. So that the underlying system, it has one set of keys that the machine uses to do the organizing, and it has a different set of keys that the human beings can use to do it. Now, you explain this to people, and you sometimes get this thing people love to say on the internet is, I just want to do technology. Please keep the politics out of it. Well, you can't put ASCII in alphabetical order without knowing what country you're in. And if you know what country you're in, you need to understand the history of how the alphabet in that country ended up the way it did. And that's politics. That's, politics and sociology. They are the things that create the problems that technology steps in and goes, I think we might be able to help you solve this thing. There is no completely politically agnostic technology. Even like in Norway, if you go in a Windows Explorer, the list of file names in there, you need to understand the history of the 20th century to know why they're in that order. Now, it's tempting to think, well, there must be something here we can all agree on. Like, can we at least agree that every letter in the Unicode set, we have an uppercase and a lowercase version? And, most of Europe goes, yeah, it's fine. United States, Canada, Norway, Sweden, Germany, Denmark, France are all like, yeah, that's all right. Turkey comes along. Turkey goes, no. Now, when I was originally scheduled, when Xpand was going to be in September last year, my itinerary, I was going to fly out and then I was going to fly back via Istanbul. And so I had this appointment in my Google Calendar. And if you look closely, you'll see that in Turkish, the capital I, there is a dotted I and a dotless I, which is fine. They got this one letter which has a dot on it, and there's a big version, a little version. Got another letter, doesn't have a dot on it. There's a big version and a little version. But when they rationalized the kind of Turkish orthography in, I think, 1934, what they decided is that if there is already an English letter that's the right shape, they'll use that one. And if there isn't, then they'll add a different one. And so you take the word internationalization and you uppercase it, or internationalization, you lowercase it. The highlighted letters here are extended Unicode characters, but the other ones are regular ASCII. So if you have a Turkish encoding set on your system and you flip from lowercase to uppercase, ordinary ASCII turns into Unicode and back again. And Wikipedia has this lovely understated, this has caused some issues in computing, it says. And this has caused all kinds of chaos. Now, let's take a look at this. Now, the thing you got to remember about Unicode, it's not trying to fix anything. It's not trying to tell anyone how to do their job. It's just looking at what human beings do and going, well, okay, let's see if we can come up with a way of doing that in technology, in software. If you need to write this symbol, you can do it this way. You can say, yep, just give me a C. Or you can combine it. You can say, I'm going to take the regular ASCII flavored C, I'm going to put a little hook on the bottom, and that's going to give me the Sadir output here. And these things can stack. So you can take combining characters, and you can say, give me a Z with a one of these, and a one of these, and a one of those, and a one of those, and that's how we get Zalgo text, which crashes some Samsung phones and shows up on Stack Overflow. Now, we take our friends in Motley Crue. We got 2 different ways we can encode this. We can do it that way, or we can do it using regular ASCII with combining characters on it. And so this gives us these 2 different forms. Now, are these the same string? Because they're different lengths, right? Different sequence of bytes, different sequence of values. But if you're searching in a database, you don't want to have to worry about how it was encoded. You just want to type something and get results back. And so Unicode steps up and it says, we're going to give you 4 different ways of figuring this out. We're going to give you a decomposed form, which is where you break everything out into the widest number of characters. And we're going to give you a composed form. And then it's also got a mode, now they've already used the word C here for canonical, so they use a K to stand for compatible. Compatible decomposition, compatible composition. And what this means is you can take a bunch of code like this, and we can say, all right, let's put in, we got our motley crew here, but we're going to put it in with the combining character. And then we're going to run this little comparison script, and it's going to say, you know what? They're the same length. This is .NET. .NET figures that out for us. They're not equal, but they are equal under all 4 different forms of Unicode normalization. Now, if we take this example, this one we got bubble text. And bubble, it still says plain text, but it says it with little circles around it, so it looks cute, right? And we're going to run that through our comparison algorithm here. And what we're going to find out with this one is it's going to say, well, no. The canonical forms, false, not equal anymore. But the compatible forms, yeah, we know what's going on here. So again, Unicode is like, you do this however works for you, you weird humans. You have your fun. We're just going to give you the tools to try and solve the problems that your users have. Now, the second chapter, my first encounter with text encoding was the pound sign on my homework. The second kind of chapter in this was at work about 10 years ago. I go in one day, one of the guys at work says, I think we've been hacked. Now, this happens all the time when you work in tech, because, they right-click, they reveal codes, or they view source or whatever. This was a really competent security engineer on my team. I said, why do you think we've been hacked? He said, there's Chinese in the Windows event logs. And there was. English company based in London with mainly British customers. We do not read, write, speak, or understand Chinese. We don't do business with China. There is Chinese in the Windows event logs. Now, this is one of those fun experiences where when you've got a good team, you delegate. So I say to somebody, right, I want you to go talk to the business. Tell them we might have a security breach. We'll have an update in 15 minutes. You, go check the firewall logs. See if there's any suspicious activity. Look for, mainland China IP addresses. You, see if there's any evidence of this in our, is this a SQL injection attack or something? I'm going to sit back and post about it on Twitter because that's what management is. And Twitter solved the problem, because straight away I get a reply back, and that looks like a mapping error. And then fake Unicode says, yeah, UTF-16LE being mistaken for UTF-16BE. And I'm looking at something, and I should probably learn what those things are, because that sounds like that might be important today. And so I dive headfirst down this Unicode rabbit hole, and this is what I learned. Internally, Windows, Java, JavaScript, a lot of operating systems, they use 2 bytes for most things, UTF-16. So something like ASCII is actually ASCII with an extra byte that doesn't have anything in it. If this gets flipped around so it's backwards, what happens is you get teleported into the Unicode block, which is used for writing Chinese. And so you get all these obscure symbols out of it. Now, I shared a version of this talk on YouTube. I got a comment from someone going, hey, if anyone's interested, this is what that actually means. This one is dismembering a body of livestock. This one's climbing. Now, when this happened, one of my team ran it through Google Translate, and they came over and said, I think it might be a ransom note. I'm like, what do you mean? It's like, they want us to kill a duck and put gold in its mouth or something. I'm like, I don't think that's what they want us to do. So the question was, why is our SQL database server flipping from big endian to little endian? Well, it wasn't. We had a faulty network switch. And what was happening is every 2.5 minutes, it would drop 1 byte from the data stream, just disappear, which meant everything else would get shunted sideways. And so for 2 or 3 minutes, English would become Chinese, and then 2 or 3 minutes later, it would drop another byte, and everything would switch back to being English. It took us 30 hours to figure out what the problem with that was. Now, this was a crash course in the world of UTF-16. Now, if we go out onto the web, UTF-16 works brilliantly for operating systems because everything's local. Memory, hard drives, everything is local, everything is fast, and being able to go, I want to know how long that string is, how much memory does it take, that's a big advantage. Once you get out onto the web, network becomes the limiting factor. And so if we take a web page like this one, now this is written in Ukrainian, but HTML is not written in Ukrainian. If we put the byte stream for UTF-16 on here, this is the bit that actually needs the extra byte. The bit in blue here, that's Unicode. The rest of it is just plain ASCII 1965 7-bit flavored text, which means that 44% of this data stream is just going null 3C, null 21, null, 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 which is a massive waste of internet, right? And so one of the most, I think, brilliant hacks that has ever come around came out to solve this problem. It's a thing called UTF-8. And UTF-8 says, look, you got a bunch of bytes coming at you in a data stream. Look at the first byte. If the first byte is 0, this is 7-bit 1965 American flavored ASCII. If the first bit is a 1, look at the next one. If it starts with 110, that's the beginning of a 2-byte sequence, and then the next bit is the continuation, and then if you ignore that bit, the bits that are in red here, that's the number you actually look at to work out what character this is. 1110, 3-byte sequence. 11110, 4-byte sequence. And in theory, so on up to 8-byte Unicode sequences. Now, this gives us a massive amount of headroom, and that's cool because we keep inventing new languages. Like emoji. Invented in 1999 by a guy called Shigetaka Kurita. He's working at a Japanese mobile phone company. They wanted to do traffic, and they wanted to do like transport timetables and fast food. And he created this original set of 176 emoji. Massive hit in Japan. Within like 2 years, you couldn't sell a phone in Japan that didn't have emoji on it. So when Apple launched iPhone in Japan in 2008, it has to have emoji. People all over the world are like, hey, go into settings, switch on a Japanese keyboard, and you'll be able to add these cool little things. And people start asking questions. You know, why is there sushi, but why is there no tacos? There's like an airline pilot and a firefighter. Why do they all look like men, you know? Now, Unicode became a way that we communicate about ourselves, the way we see ourselves. You know, what's our place? How do we fit into the universe? In 2015, Unicode said, you know what? Well, I got an idea. Let's use the combining characters like we did for the Sadir and Francois, and we'll use them to modify the skin tone on certain kinds of emoji so that you could have smiley faces and thumbs up. Now, if your device supports it and has the artwork, you get this. If it doesn't, you get thumbs up plus a little question mark in a box, and you know that it's time to go and install that new iOS upgrade. Now, you can stack these things. The emoji for a female astronaut is a woman, and then a thing called a zwidge, a zero-width joiner, and then a rocket ship. And if you don't have the artwork, you get a woman next to a rocket ship, and you can figure it out. And a dark-skinned female astronaut is woman plus a dark skin tone plus a zwidge plus a rocket ship. Now, flags is where emoji gets really interesting. The flag of Jordan is a J, regional indicator symbol letter, and then an O. This is because Jordan is a country recognized by ISO in the United Nations. It has an ISO country code. England does not. England is a country when we're playing football and rugby. England is not a country at the Olympics, and England is not a country when it comes to the ISO. So the flag of England is a black flag, and then this little tagging sequence, GBENG, Great Britain ENG. The flag of Wales, the flag of Scotland, the flag of Texas are done using the same system. And the pride flag is a white flag, a zero-width joiner, and a rainbow. Now, this flag here, any of you recognize this? Taiwan. Actually, it's the Republic of China is the official name of this country, but yeah, it's Taiwan. And in mainland China, in the People's Republic of China, this symbol means Taiwanese independence, and it is not allowed. And if you go onto your iPhone, I can type Taiwan, and I get, hey, yeah, I know that one. Look, you got a little flag for it. But then if I go into my phone's region settings, and I change the setting here to China mainland, when I reload that message in a second, it's in here somewhere. There we go, China mainland. Yep, switch that. The flag has disappeared. This is the compromise Apple made to be able to sell iPhone in China, is they said, you know what, okay, if someone sets their phone settings to China mainland, we won't show the Taiwan flag, we'll just show this little empty placeholder for it. Flags are political. Flags are really complicated. If I open a text file on macOS with a bunch of flags, Kenya, UK, Zimbabwe, Mozambique, Romania, if I open the same file on Windows, I don't get any flags at all. Windows doesn't have any country flags. There's only 3 flags supported in the Microsoft Windows operating system. They're the pride flag, the pirate skull and crossbones flag, and the Formula 1 flag that means you just won the motor racing. I don't know, is this Microsoft trying to send people some kind of message about they think gay pirates are winning. I have no idea. But Microsoft Windows, this is what they support. And I want to wrap up today by just telling you one more little story about my first visit to Ukraine in 2016. And I went to a conference in Kyiv and I was kind of walking around. It was amazing. I couldn't read, write, speak the alphabet. I had no idea what was going on, except I realized I could read the license plates on the cars. And I said to one of my hosts out there, I was like, we're having dinner. I was like, hey, why does Ukraine have license plates in English? And he looked at me like, we don't know. What are you talking about? That's not a thing. So I did the research, and I found there's a thing from 1965, the same year as ASCII, called the Vienna Convention on Road Traffic. And a whole bunch of countries, including Jordan, are signatories to the Vienna Convention. And one of the things it says is, look, if you're going to drive your cars into each other's countries, we should all be able to read each other's license plates. Now, the Jordanian solution to this, license plates here, they're just numbers, aren't they? They don't use letters on them. The Soviet Union had license plates that look like this. This is not Latin. This is Cyrillic. This is Russian. But then in the 90s, when the Soviet Union collapsed, they overhauled all the vehicle registration in those countries. And what they did, and I think this is really clever, the new Ukrainian government registration system, they said, well, we got these two alphabets. We got the English alphabet or the Latin alphabet, and we've got the Ukrainian alphabet. We're going to take the set of shapes that is common to both of those alphabets. So it's not the same sounds, but it's the same glyphs. And they said, we're going to use that as our vehicle registration set. And if you take this set of letters and you rearrange them in English, it says this, Pike Matchbox. Now, I want you to remember this, because next time somebody says, I'm going to send you a plain text file, you can just say to them, do you know about Pike Matchbox? And if they say yes, then they've seen the talk. And they know about big endian and little endian and Unicode and the Danish spelling reform and collations and code pages and all this kind of stuff. And if they say no, well, what is Pike Matchbox? Then they're going to send you a file that works on their machine. And if it works on your machine, well, good luck with that. And folks, I just want to dedicate this talk to this guy who watched the whole thing on YouTube and then at the end said, leave politics out of software, thank you.